What we're going to see today is what exactly a quadratic equation is, and we're going to see two methods for solving them. There's four common methods for solving quadratic equations. We're going to take care of two of those today. We're going to solve them by factoring and by using the quadratic formula. The first thing that we need to do, of course, is establish what is a quadratic equation. What does it look like? And then, after we understand what they are, I'm going to introduce two methods to you. We're going to solve them by factoring, and we'll solve them by using the quadratic formula. But what a quadratic equation is this. We've worked with linear equations quite a bit. Linear equations were always of this form, y equals mx plus b. Way back, this is probably about 3 weeks ago now, I told you how to spot an equation that was linear. Do you remember what the criteria was for an equation and how you could tell it was linear? All the exponents were no greater than 1. Okay? And that's what made a linear equation. Well, now we need to open it up a little bit. Now we're saying if we have an equation where the exponents can be as high as 2, those are called quadratics. Now we're going to do several things with quadratics over the next 3 or 4 days. We're going to solve them using 4 different methods. We're going to graph them, just as you can look at the equation of a line, such as y equals negative 3x plus 2. Look at the slope and intercept and think about what that's going to look like. You can do the same thing with quadratics. You can look at a quadratic equation and you'll be able to tell approximately what it looks like. That's what we're going to do on about Wednesday or Thursday. Basically, a quadratic equation is just a polynomial of degree 2. That's the fancy name for it, but that's kind of a lengthy name, so we just call them quadratics. It's important to note that when you're dealing with a quadratic, standard form is what you see on the screen there, ax squared plus bx plus c. For all the methods we're going to use, it's important to, if you have a quadratic that's not in that form, rearrange it so that it is in that form, and then we can apply any of the methods that we're going to use to solve, but we have to start out with it in that form. Now, there are 4 ways to solve a quadratic equation. 3 of them are convenient. 2 of them are practical, but they all have their purpose. The first method is factoring. That's what we're going to do today. And the second method is by using the quadratic formula. That's the second one we're going to do today. Tomorrow, we're going to solve them by completing the square, which is a tool you'll use in math that you might take in the future. And third of all, we're going to graph, and we'll do that tomorrow. Now, first of all, we're going to solve by factoring. What we need to know is this. We've used this fact before, but this is called a zero factor property. That is, if you have a product of 2 values, and that product is equal to 0, one of them has to be 0. They can't both be non-zero and have a product of 0 no matter how hard you try. In fact, I'll give you extra credit for that too. If you can find 2 non-zero numbers that when you multiply them together give you a 0, you let me know. I'll give you extra credit and $20 cash. Now we're going to start looking at some examples. The first kind of quadratic, though, that we want to look at is called a pure quadratic. A pure quadratic is a quadratic where b equals 0. That is to say, in the general form of ax squared plus bx plus c, which is just a general quadratic, b is equal to 0. So what it means is a pure quadratic is one that has no x term. It's simply, whoops, I missed a x there. It's simply ax squared plus c equals 0. That type of quadratic still is of degree 2. That's what makes it a quadratic. But there's no b term. Could you have a quadratic equation, going back up here, could you have a quadratic equation in which c was 0? Sure you could, and we're going to do some of those in a little bit. Could you have a quadratic equation in which a is 0? You can't. If a is 0, then what have you got? Well, you'd still have bx plus c, which would be the graph of a straight line. What makes it a quadratic is the fact that there's an x squared term. If it doesn't have an x squared term, then it's not quadratic. Then it's just a straight line. It looks just like mx plus b. It looks like the equation of a straight line. So in fact, the a term has to be there, otherwise it's not a quadratic to begin with. Now, we can solve pure quadratics by factoring or by using the square root function. And we're going to do an example now, and I'm going to show you both methods of doing that. 4x squared minus 25 equals 0. Let's solve this by factoring and by using the square root function. Well, let's start with probably the more intuitive method, and that's using the square root function. We just want to get x by itself. Okay, so this is an equation. You could have solved this a few weeks ago just using the get x by itself principle. Let's solve that by adding 25 to both sides. And we get 4x squared equals 25. Now, you want to get x by itself, so you need to divide by 4. And we're left with x squared equals 25 over 4. Now you're almost done. The last thing you got to do, square to both sides. Now remember, we're applying the square root, so it could be plus or negative. So y is equal to plus or minus the square root of 25 over 4. But the square root of 25 over 4 is the square root of 25 over the square root of 4. And we can say that x has got to be equal to plus or minus 5 over 2. There's our two solutions. Okay, we solved it. We used the square root property. Now let's solve it by factoring. Same problem to begin with. In order to factor, we have to have it in the form ax squared plus bx plus c equals 0. In other words, we just have to have it set it equal to 0. Now, if we want to factor that, well, we do want to factor. That was kind of a dumb thing to say. If we want to solve that, we can do so by factoring. So, will this expression factor? What form does it have right now? Difference of squares. That's a perfect square. That's a perfect square, and they're separated by a negative sign. So we know that this thing will factor in 2. First terms are going to have to be 2x and 2x. Difference of squares means we're going to have plus and minus. And our last two terms clearly have to be 5. So 2x plus 5, 2x minus 5 equals 0. Now, we're going to use that property that says if two things multiply together equals 0, one of them has to be 0. Or either one of them can be 0. So we solve this part of it. If 2x plus 5 equals 0, and we can solve that, we get 2x equals negative 5 by subtracting 5 from both sides, and x is negative 5 halves. Or 2x minus 5 could be 0. Add 5 to both sides, and we have 2x equals 5, and so x equals 5 halves. Well, there they are. There's the same two solutions. There we had plus or minus 5 halves. Here we have plus or minus 5 halves. So we got the same solution. All right, well, let's do another one. We know that we can't have more than two solutions. Can we have less than two solutions? Well, we'll leave that question open-ended for a little bit. If, now remember, the case that we just did was a pure quadratic. That was where b equals 0. And when b is equal to 0, there's no x term in there. You could use either one of these two methods. If it's not 0, then we just factor. It eliminates this left possibility. You can't use the square root property if you have a b term. You can still factor. In fact, that's what you have to do. So, if we do have a b term, that is to say b is not equal to 0, we can try to factor it and solve it. So let's do that with this example. We have 4x squared minus 10x equals 0. Factorable? Absolutely. We can factor out 2x times 2x minus 5. And now we'll use our zero product property. Either 2x equals 0 or 2x minus 5 equals 0. And we solve both of those. Well, if 2x equals 0, clearly x equals 0, or x is equal to 5/2. There's our two solutions. Crooked, but there they are. X equals 0 or x equals 5/2. Again, we got two solutions. Set it equal to 0 and factor. Now, based on this trinomial, x squared minus 4x minus 21, what's your value of a? What's your a coefficient? 1. What's your b coefficient? -4, and c is -21. When factoring, you don't have to recognize that. It's just worth noting at this point. So, there it is. Not every quadratic is going to factor. It's important to note that, but since we're doing factoring, the ones we're doing right now will. That'll certainly factor. We're going to have x and x and -7 and 3. Okay, so once we got it factored, we're home free. We can have x minus 7 equals 0 or x plus 3 equals 0. And then solve both of those and we've got our solutions. So either x equals 7 or x is -3. There they are. And we're done. What's the first thing that we need to do based on the way it sits? We need to rearrange it. Right now, it's not in the form ax squared plus bx plus c, so it can't be factored. We're out of luck. There's nothing we can do with it the way it sits. So we have to rearrange it. Best to leave the x squared term positive, so even though you could shift that to the right, then we'd have -12x squared. That makes it harder to factor. Leave the 12x squared positive. And so this will become 12x squared minus 19x minus 18 equals 0. Okay? Okay, well, we want to try and factor that thing. Just to save a little bit of time, I'll just tell you how it factors, but how would you find the factors? Remember how you do this? Hopefully so. Gabe would use trial and error. What would the rest of you use? 12 times -18. You'd multiply those two together and then find two factors that add up to -19. That's right. It turns out that would factor. Oh, let's just do it. 12 times -18. 12 times -18 is -216. Now, what are two factors of -216 that add up to -19? They probably jump right off the page at you. They are -27 and 8. Okay? Okay. Well, anyway, based on that fact, we can then split this thing up and say 12x squared minus 27x plus 8x minus 18 equals 0. Now we can continue our factoring. Split that down the middle, and we have, let's see, 3x can pull out of there. 3x times 4x minus 9. And here we can pull out a 2. And we have 4x minus 9. And so there, we've got it factored. It factors into 3x plus 2 times 4x minus 9, and that's equal to 0. Now that we have it factored, we can find our solutions. 3x plus 2 equals 0, or 4x minus 9 equals 0. So we can solve both of those. If we solve this one, we get x equals negative 2/3. And if we solve this one, we'd add 9 to both sides and divide by 4. X equals 9/4. So there's our two solutions to that equation. We can clear up? Okay. Last one before we go on to method 2. Let's solve this. Now here's a case where we have a fractional equation. That's not new. The quiz I just passed back had fractional equations on it. But all the fractional equations that you've done so far have been set up so that all the x squared terms cancel off and you only have one solution. Now things are opened up. Now there might be more than one number that makes that true. Okay, well, we're going to see how long the weekend was for you. How do you solve a fractional equation like that one? What's the first thing you got to do? Fractional equation? Find a common denominator, right? Then we're going to clear off the fractions. So we're going to find an LCD. Our LCD here has got to be 4x plus 7 times x plus 7. There's our LCD. Now we're going to multiply everything by that LCD. That'll clear off the fractions and we won't have a fractional equation left. All right? So let's multiply everything by our LCD. Let's multiply this by 4x plus 7 and x plus 7. And we're going to multiply this by 4x plus 7 and x plus 7. Now, of course, you're going to get a bunch of canceling. That's the whole reason you do it. So you got 4x plus 7's cancel over here. We're left with 3x minus 1 times x plus 7. That's equal to, what are you going to have on the right? X plus 1 times 4x plus 7. Okay, so now we've got an equation to solve, and that's free of any fractions. No fractions at all. Okay, well, now we better FOIL these out. So we have 3x squared plus 21x minus 1x minus 7 equals 4x squared plus 7x plus 4x plus 7. Now that's a quadratic equation. It's not in the form ax squared plus bx plus c yet, but it will be after the next step. That's a quadratic equation because what is it that makes that a quadratic equation, even though it doesn't look like the ones we've done before? Power of 2 and nothing higher than the power of 2. That's right. It's got powers of 2 in it. And there's nothing higher than that. Okay, so if we start combining terms, let's take that 3x squared and subtract it off both sides. Let's also, we're ultimately just shifting everything to the right. So let's add 7 to both sides, get this thing equal to 0. At this point we have 21x, that's 20x, equals, you could do these in any order. I'm just doing an order that won't get too messy. 4x squared minus 3x squared, that's x squared, plus 11x, plus 14. Now it's almost there. We just need to get those x's over here also. Now, why did we do all that again? Why did we take everything and push it all the way to the right side? Now it's equal to 0. Now it's of the form ax squared plus bx plus c, which means now we can factor it. Now we can factor it, and we can finally finish this thing up. So at that point, we can say, all right, 0 equals x squared minus 9x plus 14. So in this case, 0 equals x. Squeak this over a little bit. I'm running off of my safe spot here. This means 0 equals x minus 7, x minus 2. So x minus 7 equals 0, or x minus 2 equals 0. Well, in this case, x equals 7, and in this case, x equals 2. So we got our two solutions. Now, it's really just a technical note, but are we really done with that problem quite yet? Completely? We're not yet. What's the one thing that we still got to do? Check your restrictions. This is a fractional equation. Well, if you look at this, we know we got whole number solutions, so we just need to make sure that neither of those are restrictions. Is that going to give you a whole number restriction? 4x plus 7 can't be 0. Check them both in here. Would 4 times 7 plus 7 give you 0? Nope, so that one's okay. How about here? 7 plus 7 going to be equal 0? We're just checking that one to make sure it doesn't give a 0 denominator. No problem. Same thing with 2. This would be 4 times 2 plus 7. That's 15. That's not a 0 denominator. And 2 plus 7 would be 9. So neither of those give a 0 denominator. They're both okay. Okay. Well, what's the obvious thing that can go wrong with this technique? Well, there's probably many obvious things that can go wrong. Well, that or worse yet. What'd you say? Oh, I thought you said you get married. What if it doesn't factor? Okay, what if it's prime? Well, then you're out of luck. No, you're not out of luck. You have to use a different technique. Not all quadratics will factor, but they can still have solutions. Factoring method doesn't always work. It only works if it factors. If it doesn't factor, then you can't use that technique. So if you take your quadratic, which we just did, and put it in the form ax squared plus bx plus c, which you have to do no matter what method you're going to use, you can just use this formula, and it'll tell you what the solutions are. Music video coming soon. Now, this you'll have to memorize, okay? I'm going to show you where that comes from tomorrow. We don't have the tools yet to see where that formula comes from. I'll show you that tomorrow. But you do have to memorize the quadratic equation for quizzes and tests. So we have 18 plus 19x equals 12x squared. That's the same one we did a little while ago. The first thing you have to do always is get it set equal to 0. So let's do that. And again, we're going to keep that a term positive. That just makes it a little bit more convenient. So we have 0 equals 12x squared minus 19x minus 18. Okay, so what we need to do now is we need to recognize what a, b, and c are. So let's just make a note of it here. A is 12. Everybody agrees? You better. All right. B is equal to negative 19. Don't forget the negative sign on that b term. And c is equal to negative 18. Now, once we know those, we can plug them into the quadratic formula. That's why you need to know the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. So in our case, x will equal Negative b. Now, the quadratic formula will always tell you what the solution is without a whole lot of figuring like you have to when you factor. It's just number crunching, but you got to be careful with the signs. So x equals negative b. b is negative 19. So negative 19 plus or minus the square root of b squared. That's negative 19 squared minus 4 times a, which is 12, times c, which is negative 18. All over 2 times 12. Well, there it is. There's your solution. But we got a long way to go just to clean that up. Okay, let's stop there for a minute. Everybody see how we're basically labeling a, b, and c after the quadratic is put in standard form? We substitute the a, b, and c values into the equation, and now we just have to figure out what that's worth. Look good? Okay. So we have x equals negative 19. That's just really positive 19 plus or minus the square root of negative 19 squared is 361 minus 4 times 12 times negative 18, that's negative 864 all over 24. I just squared the b and figured out what 4ac was. 4 times 12 times negative 18. Everybody okay up to there? Good? All right. Well, then we've got x equals 19. Let's continue to do this. Plus or minus the square root of 361 minus a negative 864. Be very careful when you're working with these values. 90% of problems with the quadratic formula come from missing a sign in here somewhere or losing one. So be careful with your signs. So 361 minus a negative 864, that is 1200 and, what is it? 1225 all over 24. Well, then we can take the square root of that, and our two solutions are 19 plus or minus 35 over 24. Now, this gets back to what Aaron asked about a little while ago, plus or minus. Well, it's both. Those are your two solutions. One solution is 19 minus 35 over 24. The other one is 19 plus 35 over 24. So there's our two solutions. Now let's just simplify those. The first one, 19 minus 35. That's negative 16 over 24, which simplifies to negative 2/3. There's one solution. And the other one, 19 plus 35, that's 54 over 24. And that will reduce, they both divide by 6, and we end up with 9/4. So there they are. Those are our two solutions. We want to solve this quadratic equation using the quadratic formula. Okay, well, now that you've got a little bit of experience using it already, what's the first thing that you need to do here with this quadratic equation? Yep, we're going to get all the terms on one side of the equal sign. We might as well leave these two positive, and so this becomes 0 equals 16t squared and rearrange them at the same time, plus 15t minus 100. With that in mind, we can label A, B, and C. Apparently A equals 16, B equals 15, and C equals negative 100. Everybody agrees with that? Okay, we got our A, B, and C labeled. Now, we need to recognize what the quadratic formula is. And our quadratic formula says that our t in this case, it's not always x equals. T is our variable, so it's going to be t equals negative b plus or minus the square root of b squared minus 4ac over 2a. Incidentally, ask yourself, do you have that memorized yet? Good, you should. Have that memorized soon if you don't already. So if we fill in our values, we have t equals negative b, that's negative 15, plus or minus the square root of 15 squared minus 4 times 16 times negative 100. All over 2 times 16. So if we simplify that a little bit, we have t equals negative 15 plus or minus the square root of. Now, if we work out that square root, it turns out to be 15 squared is 225, and this turns out to be plus 6,400. All over 32. So that becomes negative 15 plus or minus square root of 6625 over 32. Okay. Well, square root of 6625, we've got negative 15 plus or minus. Square root of 6625 is going to be a little over 80, I think. 81.394 over 32. Now we can compute what our two solutions are going to be. Negative 15 plus 81.394 over 32 is going to give us 2.075. Or negative 15 minus 81.394 over 32, and we get negative 3.012. So there's our two solutions. One of them turned out to be positive, one of them turned out to be negative. But we've got our two approximate solutions for t. Okay. Now that's going to springboard us into the last thing that we really need to make a note of, and that's what's going on with this square root. What happens with the different things that can arise in here, because that can be trouble and give us a negative value in there. But before we do that, questions about the selection of A, B, and C, the substitution, or working out to find our two numeric approximations? Okay. Well, what we're going to do now is we're going to turn our attention to that b squared minus 4ac, because there's a potential for trouble there. You can have, all the quadratics we've worked with so far have had two solutions. Here's an example where we had two solutions. That doesn't have to be the case. It could just have one solution, or it might not have any. And you can tell quickly how many it's going to have by looking at the discriminant, which is, in the quadratic formula, b squared minus 4ac. That's the one that we're looking at. By evaluating what b squared minus 4ac is, we can tell how many solutions we're going to have. And that's called your discriminant. It could be the case that b squared minus 4ac gives you a positive number. That's what we just had. Here's an example. If we have x squared plus 5x minus 10, there's a case where we have no trouble. In this case, a equals 1, b equals 5, c equals negative 10. So this is the quadratic formula. We're not really interested in the whole thing, though. All we want to know is what is the value of the discriminant. B squared minus 4ac. So we're going to have 5 squared minus 4 times 1 times negative 10. That gives us 25 plus 40 or 65. Now, why does that mean, having a positive discriminant, why does that result in two real solutions? Yeah, because there's something here. When we do the plus minus, there's something there to plus or minus. Okay? If we add on that root 65, we get one solution. If we subtract off that root 65, we get another solution. So if b squared minus 4ac has some value, then we're going to have our two solutions. Does that make sense? Okay? Well, the second case is, what if b squared minus 4ac doesn't have any effect? Or in other words, if it's equal to 0. If your discriminant, b squared minus 4ac equals 0, then this has no value, and the plus or minus won't matter. Then you're left with one solution, negative b over 2a. Let's work out this example and see how that shakes out. X squared minus 8x plus 16 equals 0 is what that equation should read. So, in this case, we have a equals 1, b equals negative 8, and c equals 16. So if we fill in those values, we have b squared, that's negative 8 squared minus 4 times 1 times 16. So that becomes 64 minus 64. And so the discriminant value is 0. That means we're only going to have one solution to this. There's only going to be one number that will make it true. What is it? Well, go ahead and evaluate your quadratic formula. Negative b is 8 plus or minus the square root of 0, as we just saw, over 2 times 1. That's 8 over 2. Or in other words, our one solution is 4 because there's nothing to plus or minus. It's gone. We only get our one solution. And so if the discriminant is 0, we only have one real solution. Okay, and finally, the last case that can happen is if it's less than 0. If b squared minus 4ac, the discriminant turns out to be a negative number. Then you'll have no real solutions. Again, this example should be 2x squared minus 3x plus 4 equals 0, an oversight on my part. Here a equals 2, b equals negative 3, and c equals 4. So the value of our discriminant is going to be negative 3 squared minus 4 times 2 times 4. We get 9 minus 32. That's a negative 23. So if we were to try and apply the quadratic equation, we'd get x equals negative b plus or minus the square root of negative 23. Can you take the square root of negative 23? You can't do it. And so therefore, there are no real solutions to this. There are no real solutions. Let's just start out with another case where we don't know what the solutions are. Let's use the quadratic formula and just suppose we walk into it blind. So let's take this one. Let's try and solve it by factoring if possible. Of course, you want to start by shifting everything to one side, preferably making your leading coefficient of negative 4x squared, make that positive by shifting it to the left. Okay, let's try factoring. Now we want to factor this up into two binomials. Trial and error we could do if you have a lot of time. Or, how can you check to see if it's going to factor? 4 times 8. 4 times 8 is 32. So now we want to break 32 up into two factors that multiply to give you 32 or add up to 5. Is there any two factors of 32 that will add up to 5? No. It can't be done. This will not factor. It's prime. So, if it won't factor, that method of solving is off the table for us. We can't do it. Well, you should automatically then revert to the quadratic formula. Okay, let's use the quadratic formula. We can still use it in this form. We just have to recognize now that A is equal to 4, B equals 5, and C equals 8. Well, the thing about the discriminant, when we wanted to figure out how many solutions it has, you don't have to necessarily stop and figure out the discriminant at the beginning of every problem so you know how many solutions you have. Just use the quadratic formula and the discriminant comes out in the mix. If you end up with a negative number out here, you're not going to get any solutions. If you do have one or two solutions, they'll just come out by applying this. So it's a useful tool, but it's not necessary. So let's fill in what we know. We know that x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay? So where does that leave us? We have x equals negative 5 plus or minus the square root of 5 squared minus 4 times 8. Negative 103? Negative 103. Okay, well that settles the first issue. How many solutions are we going to have to this thing? None. No real solutions. And that's over 8. So there are no real solutions. So there's no real solutions. For the purposes of this class, when you hit that, you're done. No real solutions, end of story. It's worth noting, though, later on you're going to work with imaginary numbers, especially if you're in one of the electronics programs. This would have an imaginary solution. All we do is take that square root of negative 1 out because that factors into the square root of negative 1 times the square root of 103. And we call this negative 5 plus or minus. Negative square root of 1, square root of negative 1 is usually called j times the square root of 103 over 8. We are not going to work with that at this point. It's just noting that this is an imaginary value and that does have meaning. But we're going to stop right here for now.